as per today's agenda on data science, in this webinar, what we are going to cover is, is what actually is data science. Why this buzzword is coming in the market saying that data scientist, what we do with data, what are the type of, what are the various jobs coming in, what is machine learning, all those things. We'll have a broader overview of all these things today, so that probably when we go out of the session, people can understand more about the various stuff in the current trend, right? That is what is being meant for this webinar. The agenda of the webinar would be this, right? So taking it further, I would be covering what actually data science, what are the type of data available, what sort of storage systems we have in the data, what is the entire life cycle of data analytics, right? So that would cover one particular section of today's webinar. And then further going ahead, I will be talking about what is machine learning, what type of learnings we do have, and going further, taking it from there, like what sort of job roles are there, what are the current trends in various industry, what sort of packages yearly people earn as being a data scientist, right? And some of the case studies we will see which is there in the current market. And we will be looking for programming language which are used for data science and all. And we just try to have a quick hello world sort of or first code of Python and R, right? That would not be covering the entire model building or whatsoever, but then it'll just make you to understand how things goes on in this platform, right? As per the conventional coding stuff, it's similar to those way, right? Yeah. So let's get started. Actually, what things are there in, right? Data science is a buzzword which is going around the market now, right? So what actually data science is? Data science is probably you can define as combination. I mean, if you want to know more about it, right? You want to extract the meaningful information from data. Either the data can be in the raw format or it can be structured, it can be unstructured format, right? That is what actually data science is. Data science is the process of extracting meaningful insights from raw data, which can be in structured or in unstructured format. Let's get into more detail about data science now in the business perspective, right? So it talks about, if you have a pretty good knowledge of domain for a given, like probably like can be an automotive industry, can be on in healthcare, it can be on aerospace stuff. If you have a proper domain knowledge and a bit of computer statistics, computer programming language, and some statistical or mathematical basics, you can be a better data science scientist in this domain. So the right data science can be drawn out of all these areas. So probably there are other stuffs like if you have domain knowledge and maths background, you can be a better statistician or a researcher there. And you're very good with computers and maths, you can be a machine learning expert. And if your domain knowledge is strong and you are good at computer science, probably you can be a data processing guy, right? So you can extract whichever data is relevant to those to be processed, right? All these things comes in. It is a traditional which being created by artificial design. So I've got some references for that also, right? Those things in there. What actually data science is not, right? It's not a piece of software end to end which gives you a overall like an app or web application, but it provides you the insights from the data. Probably it can be a dashboard, it can be the results generated from any sort of like the data, which raw data it has. It gives some insights, can be represented in the form of dashboard or can be something like that, right? So it's not merely about visualization, the stuff's there, but ultimately goes through an entire process of gathering the data, filtering out the important stuff there and all these things, right? It's not more related to academics research, but it is like it's more of providing business solution as of stuff there. Probably data science is maybe being started with the academic research, but It's not restricted to that, right? To justify this point, I would like to provide more business solution rather than academic researches. Right? Those things like that. So taking this bit of introduction from data science, we will move on to the various jargons of data science coming from the history, right? What actually is machine learning? What actually, when it was coined and what are the things that were described in there, right? So taking the history back from there, the jargons, if you see, in 1980s, they focus on algorithms and the amount of data was very limited. As you see, the web applications got into the servers and the central server used to manage the entire data because earlier web applications used to be, or not web application as such, applications used to be standalone and the data would be on their local hard drive. There was no any other central storing systems, right? So that's where it was bit tedious to gather the data. But as and when the web application started in 1980s or whatever, right, they got the data in one place now. And they focused this researchers, scientists, they were focusing on building the algorithms on to train the model or whatsoever. So with this sort of data, they were looking for machine learning stuff. And predictive analytics are more when the data was gathered more and trying to predict what things are there based on the earlier data patterns, right? They use the algorithm that were developed and applied on large amount of data. Those things were being done in late 90s or the beginning of 90s, right? So another stuff where big data analytics came into in the era, I mean decade of 2000, which were focusing on computing on big volume of data as in decades grows, right? The data gathered was eventually growing day and day, right? So that point of time, it started with the big data analytics stuff, right? So probably the data would be in distributed fashion and all those things. They used to gather those and then do some analytics and get some insights from it, right? So now if you see, we have computation power as like huge servers are available, AWS is there, Google have come up with its own GPU, TensorFlows and all those things. Being huge data which has been from the decades we have, as well as the algorithms, efficient algorithm are coming, a large volume of data, that emphasizes, that gives you a curve to another right, another area to explore more and do something in it. That's where in late, I mean 2010 onwards, this field have started very efficiently in the drastical change of software industry have led people to look for data science actually, right? The This is sort of like background of how things moved from a traditional software or to towards the data science, right? Since we have the data now from probably like 80s to 2010 and all those things, you have data. Now what should we do with this data, right? So probably when in the earlier traditional ways or so, we used to maintain handwritten forms and all those things. That used to be done or once it is no use. But now we have electronic data which we can dig in more to understand the patterns there, or probably we can understand the customer's pattern. That's how the data science evolved from it, right? So these are some of the jargons which we can focus on. So now let's talk about what actually data which was gathered in those decades, right? So let's see what was the data actually. Okay, data is a collection of fact such as number, words, observations, measurements or observation, or even description of things, right? So it can be anything, probably a number, it can be a word or comment or video data. Entire things makes the piece of information is what you can say as data, right? So data can be of, generally you can think of data can be divided into two stuff, qualitative data and quantitative data, right? What do you mean by qualitative data? Qualitative data describes for a given piece of probably something, it describes descriptive information would be that, right? The data which consists of descriptive information is known as your qualitative data. Let's say for an example, I drink coffee every day, right? This is a descriptive information. Now looking at the other type of data, it is quantitative. The numerical part is being explained here. This is, yeah, descriptive information. This is numerical information, right? That is how you can understand actually the data if you wear the glass of data scientist, right? So you can understand how data is being divided into two different classes, qualitative and quantitative. In the quantitative stuff, let's say you will be divided that into discrete and continuous, further divided into these two sections. Discrete gives you a counted value of it, and continuous what data gives you a measurable amount of, I mean, the quantity there, right? So for an example, I drink 4 coffees every day is like 4 is your discrete value, the counted value, right? And if you say I drink 80 grams of coffee every day, this is your measurable data. Got it? The difference between these two, the qualitative and the quantitative data, right? That is what the difference between what actually the data and qualitative and quantitative. If you see some information like this, now you can put in the glass of data science and divide that into various stuff. All right. So another stuff where we can look in for data in this fashion in the qualitative branch is at the end people will do in the data science as NLP, natural language processing, right? Whatever the text corpus is being given to you, you try to extract the information from it. Probably like you want to do sentiment analysis, or probably you want to extract some of the keywords from the entire, or you want to do classification of various articles, books into various different sections, probably like sports section, politics, or current trends, new technology. If you want to classify different thousands of books, you just based on the keywords, you can classify them into various stuff. That is what your NLP is, right? It can be other various tasks can be done in NLP, right? The other is quantitative stuff. If you want to look for the end application of it, probably you can try to predict some values from the given stuff here, right? Given this, you can think of loan prediction stuff. You can provide this information to a machine, and probably we can define whether it can get the loan or not, right? That sort of prediction stuff can be done in quantitative data, right? Um, this is what a brief introduction about the data. Let's move on. What are the things which we focus? I just talked about, right? The same thing which we can use for text as well as more in more detail in this data. Right? So the qualitative data and thing is what we can do is, uh, as we know that qualitative data is your descriptive information, we can do a sentiment analysis on this. The sentiment analysis here refers to, right, probably a product is being launched, right? How people are, a movie is launched, how people respond to it, probably based on the movie review rating people give on that. It was a good movie, bad movie, or um, a worse movie, all those things, right? That can be classified into, the given corpus can be classified into negative or positive, right? If people get more positive reviews, it can be listed there in the dashboard, right? That things can be done in the descriptive information. Some of the example has been listed here. Your friend's house is pretty good. These are the keywords which makes it to be positive, right? So pretty good, yeah. Oh, good is a keyword which, or tag which makes it to be positive class, right? Amazon Echo is the best AI assistant, best, right? Those things are the positive polarity keywords, right? So these are the usage of text mining, NLP, or sentiment analysis which we can do on this sort of data. Quantitative data represents some quantities there in that, right? Numerical values or so can be defined in this. Probably you can think of a sales prediction. And when it comes to sales prediction, can be in the Black Friday and all those things, or Thanksgiving and all those things. That point of time, people wants to make their sales higher, and they want to clear their old stocks, right? At that point of time, they can stock in more uh, stuffs using sales prediction. Let's say iPhone 8 or 10 is moving fast in this coming sale. I want to make more profit as Walmart. I'll try to figure out what is the current market need, right? Based on the earlier patterns available. I'll stock in that based on the amount it has been predicted. I'll stock in that money phones into my inventory. Once that is stocked in, I can do a prediction that I can make more profit, right? If the prediction goes very well, and the sales of all iPhone 10 is being at a peak, and I can make more profit by predicting that, right? That's how we can think of like predictive analytics can be done on numerical data based on the patterns of purchase from various customers on sales, on off sales, and all those things. Taking that data, right? These are some of the examples of data and their applications in the various market as such. Okay, right. So we're now covering that, what actually data was, what things can be end used with the data. We'll move on to the next step where we can understand what are the various types of data storage, right? So it can be a structured data, a semi-structured data, or unstructured data, right? When I talk about structured data, right, it can be a traditional database, it can be an ERP system or CRM systems. Those have complete information of each column or can be various fields, right? It is in structured format. You have the entire information there, right? So traditional relational database and Oracle database and all those things are referred here. If you see the semi-structured data files, you can think of like log files or XMLs or all those things. These are semi-structured data. And if you see unstructured data, probably you can think of like Firebase, Facebook, Twitter, and all those things, where you cannot predict that this sort of data would be coming every time. Probably Facebook people can upload the text or can be uploading video, audio, or can be images, GIF, and all those things, right? These are sort of unstructured data for a given stuff there, right? Those things are there for when you consider the type of data available on which we can do some processing or analytics process, right? As such, we see we define a problem formulation. We do a problem formulation on which we want to work on. Let's say it can be an image classification or probably predictive analytics. We first define the first thing is foremost thing is to define problem, clear problem statement, right? Based on that, you try to figure out what would be the outcome for it. So, and what are the basic input data that can be gathered from it, right? Data we need to gather, we need to collect the data, do data visualization to understand more how the patterns looks like when it comes to data understanding. Got a clear picture of the trends and all the things, right? It will be more helpful to apply which sort of algorithm would be efficient enough, right? That would give you a curve to do the pre-processing. What sort of pre-processing is needed for it? What sort of pre-processing we can think of on based on the data visualization stuff. Once we do some pre-processing, we feed that model to build a model actually. Once we have done the data is very clean enough to feed into model, we go with this step. And in the model building, let's say you want to do classification, right? 1 second. So what we want to do is we want to do a classification stuff. We can classification, and then we can do prediction, predictive analytics. We can do image processing, right? All things can be taken care based on the sort of problem which we are looking for. Once we define the problem statement, according to that, we did the data preparation using pre-processing. We can have a list of model can be done, and then we'll try to evaluate the model based on the model is built on top of training data, right? And we evaluate the model using test data, right? Every time data is divided into two parts. Either it can be when you build the model, you use training data set, probably in the traditional way. We divide that using 70% here, 30% here, and some point of time we use in between a validation also. In that case, the division would be different, 60, 20, 10, 20, 20, like that, to make it 100% data. These are two different versions of dividing the data, right? So what we do is we evaluate the model based on the test data, and we then, if it is good enough, if it is accepted, we can deploy that to the production. Otherwise, we'll fine tune the model with various data parameters, create the model, build using various classification and all those things, and then iterate over to get better results. Once everything is approved, once everything is expected outcomes are generated, that can be deployed onto the production server, right? So every time data is being gathered, it will run the entire process from here to here, and then it deploys there on probably on a dashboard or something like that, right? That is what the entire data analytics process is, right? This is the entire journey of data from a raw data or unstructured data which is no worth of getting information. If we feed them to this pipeline, you get recursively better and better and at the prediction, and then you deploy the product. That is what your entire data analytics process is, right? All right. So we will move on with various other stuff. Now we will, interesting part, we will see what are the various paths that we can look for or the roles when we do data analytics or data science course here, right? So if you see the various roles that comes out of data science are data analyst, role of data analyst, or a data engineer, or a data scientist, right? So the same thing when which I talked about, like three three stuff which are incorporating all together as the data science stuff. So the role of data scientist is comes in when you are very good at programming, data communication stuff, or data understanding the domain stuff, and your maths and algorithm and stats are pretty good. You can be a better data scientist because you go through rigorously understand the domain as well, the programming language you use and all those things that lead you to a better data scientist. And probably data engineer job is to gather the data from various sources. Let's say your data is distributed across the servers. You want to gather the data, right? That point of time, there would be a need of data engineer, right? So you collect the data from various sources. Probably data engineer comes in when the data is very huge. I just put down some of the notes here. The entire job of data scientist is to develop some of the algorithm to solve some complex business problem. It can be anything, right? So generating the algorithms is main task for data scientists as such. And coming on to the data engineer, it needs to handle a huge data, right? With proper consistency and availability. Here, huge refers to probably more than terabytes or petabytes of data, not just GB, right? It can be dealt by any other programmer as such. When it comes to a huge scale of data where your industry or your software company is growing day by day with data, there will be a challenge of maintaining it entirely, right? That point of time you need a data engineer to maintain scalability, availability on all these parameter, that point of time we need data engineer there. Data analyst role is to draw the insights from a raw data, right? To understand, he has a very good understanding of domain expertise as well as some of the maths and algorithm. That is how he can draw visualizations and do some analysis on whatever the data was available. Right? That's how we can define the various roles in that are coming out of data science. Right? Either it can be a data scientist, either it can be a data engineer, either it can be a data analyst role. Based on the interest, people move on to the various buckets. The career path is clear up, having the various roles available. People can move to their respective based on their interest actually, right? And the reference for this has been given here, and you people can look in for once those. If you see the job trends available in the data science, probably this is the hottest skill available in the market as such in this decade, right? So people are shifting from programming to data to server management to whatsoever from various domains. People are looking for this course and understanding the stuff there and trying to switch their jobs from various roles to data scientists, right? Because it is being driven as of now, like the salary package is pretty huge. The normal software engineer would earn half of this, I believe, right? But now data scientists are earning more and more. Some of the huge companies are being providing a lot of attention towards data science to understand the customers pattern and make more predictions correctly in order to increase their profits and all. Right? That is where being listed. So the source for this was taken from Indeed.com. Right? Those things are there. These are the job trends actually people which see in the United States, right? So I want to do this now, getting the understanding of the roles available, the data there, what sort of processing we do. We will look further ahead with what is machine learning, right? What do we mean by machine learning is, right? As per the Arthur Samuel, he stated that the field of study which gives computer the ability to learn on its own with or without explicitly programmed is you call as your machine learning. You provide the data for it, it understands the data and try to learn the pattern in it, right? That is what is being said by the Arthur Simon. So how do you do that machine learning stuff? You teach that machine using the data which is available. Probably it can be a sales data, it can be image stuff, right? For classification of images, it can be a text to do classification of various PDF files, right? Into various buckets, can be in politics, sports, right? Sports. These are the various buckets. Politics, it can be something like that, right? I mean, any technology and all those things. That would be the various buckets. So your job is to classify 100,000 different PDF and 100,000 PDF. It will be a tedious job to classify that into three different buckets. But once you create the model, your machine is learned with these keywords. It belongs to a sport. It would be very easy for this number of thing to be automated, and then probably you can get all this divided into various buckets which all classified version of, right? That is how you teach machine in order to carry out your daily activity, right? Once, yeah, probably the data has been given there, you apply various machine learning algorithms, you evaluate the model. Once the model is perfect, you apply there and you get the results, right? That are some of the use cases people will make in order to understand the data. Yeah. So going further, I would just like to quickly see what are the questions are there in this. Um, Python, at that point of time, you either use Jupyter or Spider is what we can think of. Big data is what people look for. I mean, this is not much related to big data as it's like data science is altogether consists of data engineering, data science, where you can think of model building and all those things, right? Those things can derive from data science, big data engineering and all those things. The type of learning we do here in data engineering, data science, right? So it'll be like supervised learning. Model is trained on the labeled data and the outcomes are monitored, right? That is such learning which we did in when we were child. Like we used to be mentored by our teachers or guardians or so to understand this is this is that, right? They trained us to say that this is a cat, this is a dog. These features belongs to a cat, these features belongs to a dog. That is where you were trained. That is that sort of learning is referred to as supervised learning. Learning under someone's supervision is called your supervised learning, right? And in the unsupervised learning, what we do is the model is learned without any labeled data. So probably I forgot to put in here. It is without, right? So without any labeled data, it's on its own, right? So that sort of learning is called unsupervised learning. And semi-supervised learning is a combination of both labeled and unlabeled data. Reinforcement learning is a self-correcting way of learning, where for every success it gets rewarded, and for every failure it gets penalized, right? That sort of learning we can see that in cognitive thinking of a robot, right? That is how we can see that in robots, where people come in. Let's say for an example, I ordered a robot to get me a glass of water, right? He will get me a glass which consists of water. At that point of time, I will that point of time, what I'll do, I'll say, good job, robot. So every success will get rewarded. So here reward refers to a good job, right? Right? This is a reward for him. Or at the point of like failure, if instead of getting me a glass of water, it brought something else, right? I would say, crappy pot, you didn't follow what I said, right? These would get sort of like penalized stuff to a robot. Those things are the main factor in reinforcement learning. Right. So another example, if you consider in the real time, being a child, if you ignite a candle and put in your hands, it gets you burned. But prior to that, you were not aware of it, right? So now the next time, what I learned from this action is every time I put my finger onto a candle there, it get burns. The next time it got penalized, right? When you put your hands on the candle, it got penalized by burning. So next time I would not follow this path. Rather, I would go avoid putting hands on candle, right? That is how you learn from the experiments. Okay. Label data in the sense you know the outcome. All right. I'll just put down some example for this label data. Right? Yeah. So let's say consider an data of a bank. Okay. I'm bad at this drawing. I will just put in some information here. So this is your Y value or prediction value to be taken care of. This is probably a loan or banking detail information, loan either to give or not. And the information is from bank sector, we got it, right? This is probably your age, this is your salary, this is your credit card billing, this is your spouse working and all those things, right? This on this data has to learn whether to give loan or not. So probably in the age of 25, and the salary is more than $90,000, and you don't have credit card, and your spouse is also working, you get the loan there, right? This is your label. This is your outcome. Label data here refers to the outcome there, right? This is your label data. Some point of time you won't get label Y value, and these refers to your X value, and this is your Y which you need to predict it. These are also referred to as independent data. This is your dependent data. So these are the types of learning which we can see of, right? What are the other futures of you? We can look for various use cases actually in machine learning and data science, right? So probably if you see, there are a lot of things coming in the market: the chatbot, sentiment analysis stuff, Walmart prediction, self-driven cars, facial expression recognition, and image tagging, right? These are the entire stuff that you can see in the current data science and machine learning stuff. If you see, these are the trends. People might be aware of, like portals used to have earlier manual people being chatting there. Now it has been automated as this conversation is being stored in your database. The way, let's say, use case of troubleshooting of a particular Windows system. People used to ask how to troubleshoot my network adapter, and the appropriate answer is available in the chat history. So model is trained on those questions and answers, and whenever a given question relates to that, it will give you the appropriate answer. That's how you create the chatbots there, right? So sentimental analysis, we saw how movies can be reviewed positive or negative based on the comments back. Sales predictions are the one which we can predict and increase the sales of a given grocery store. Coming on to the next future of machine learning and all, self-driven cars, people, giant companies are putting a lot of efforts in generating it. Like Google, Tesla, and all those things are putting their lot of R&D projects there. One of the example which I want to give more emphasizing on it is facial expression recognition. One of the interview, one of we being faced was from probably a company where they were looking for a Skype interview, and the Skype interview at the background, what they were running is an algorithm which tries to detect the emotion when you give an answer, right? So if you are probably at the happy when once the question is asked and you are happy, it gives you another parameter that he was confident enough on this answer. So independent and dependent data is Y value is dependent on these stuff. Independent stuff are the one which on which you can derive. Uh, there's no dependency on these values, right? The outcome is totally dependent on these parameters. That is how you can think of dependent and independent data. So coming back to the use case which we were discussing now, the current trend is more towards the image processing and all those things. The way people used to see image frame or all those things, right? That is what we are doing the image tagging now using computer vision. So now people can see what things are there in a particular image. This image consists of tablet, a bottle of water, glass of water with ice and lemon. All things are being trained, pre-trained model which can classify and put in a region boundary of region to that, right? Or if we have such model being trained, you can tag that image using various tags to it, right? This is one of the ongoing research area people are trying to make computer to understand the image in the visual context, right? That is the future of computer, like machine learning and data science. Okay, going back, yeah, from here, what we will do is we'll see what sort of programming language that people uses in data science and machine learning stuff, right? So generally for when to use which programming language is a big question here, right? So RStudio and Python are the two platforms which you can work on, or you can look for SAS or as well. And other tools are available, but these are the core components of your programming language in data science, right? When you're looking for statistical analysis, right, R is very good at it. Regression trees or whatsoever coming in the market. If you want to do statistical analysis, R is very good platform for you to work on. And if you want to work on the text mining, sentiment analysis, neural nets, deep learning, and all those areas, Python has very good libraries and all those huge packages available for that. That is what the use case you can bring in to understand the stuff there. So there are various other things that can be considered in choosing of programming language. The RStudio has a good community support for our public and people. If there is a concern, a lot of programmers are available in order to. There are various packages to do visualization using ggplot and ggplot2 and all those things. These are the stuff. TensorFlow and Keras are the deep learning libraries where it is used for generating a model on computer vision or can use for word to vec and all those things, right? Actually, if you go for deep learning stuff, that point of time you use these libraries, like TensorFlow and Keras for deep learning. Deep learning in the sense you might be aware of neural networks and all. At that point of time, you can use these libraries, right? So what we will do is just go through a quick round of Hello World in RStudio in order to understand what things we can do with R. So I have already installed that in my system. R has been installed in my system here. Looking for your, so I just want to give a quick introduction about the RStudio. There are 4 sections in it. Probably one is your R script, another is the environment, another is the console, and various other files and plots and all those things you can see. So this window consists of four sections when you can where you can run your code, you can have your console here, global environment stuff, all those things, right? Those things are there. If I just want to say print hello world, right? What I just need to do is it's more of like very interactive programming language. I just said, oh, hello world. What happens is it understood that as a function internally. It has a function where you can pass in a parameter. The parameter which I passed was hello world. It is printing it now, right? So some of the arithmetic operations you can directly do, since it has been more towards like a statistician way of building that. You just need to do a basic operation and hit control enter. It does that. Probably you can do multiplication, whatsoever you want to do, you can try out that. So you can see the results there. Let's say I control enter. You can see this results in the console. This is the script area where you just can enter the scripts, whatever you want to do. And this is the result area. Let's say I want to store a value in a variable, right? You got a value and a variable, a memory is allocated for it, right? That is how you can understand the stuff there in the Python R code, right? Similar to that, we have two different various IDs available. Yeah. So R you can install using these particular links, right? You can go through those documentations there. Python can be installed from this. If you want to do data science stuff, Anaconda is a suite which consists of all the other data science stuff which can be used as the ID. The suite of IDs available in the Anaconda and the environments there. So you can use various environment of Anaconda in order to do your stuff. Probably TensorFlow and all those libraries can be installed there in Anaconda. So the various IDs that are available is Jupyter Notebook and Spider. Jupyter Notebook are I'll just pull out those IDs first of all in order to show you what things are there. Okay, this is a typical IDE is similar to RStudio, which is a spider. It runs the code at a granular layer, saying it runs the code at line by line execution of the code would go line by line as we did in the RStudio, right? So similarly, you have another stuff which is Jupyter Notebook. What you need to do is you just need to type in the command called go to a location. You just need to type in command Jupyter Notebook. It runs a particular server in your local instance with this port number, right? Once you have that, this points you to particular stuff there. You create a new Python file, and then it gives you each point of time you can run code there, right? So probably you can do print. This is how you can do that in Python. So this is one way. This is another way. You just write in here. This beneath that the compiler is saying you can see those things here, right? So script is here. The outcomes in the console are here. These are the environment variables as same as the R environment which we just looked in, right? Similar to that. The scope of like declaring type of variable is not needed. Yeah, the type is not needed because it is like more towards the question being asked, like declaring type of variable is not needed. As such, R was developed by statisticians. They don't want to maintain constraints of having all those functionality and all those things, right? They just want to make a specific language which people can understand easily. So that's where they have not have the constraints of having the variable declaration and then initialization of that stuff. Okay, that's the answer for it. We want to do some visualization and show the results to your manager or to your lead or so. Execution stuff back to back, right? Let's say I've added one more and I say 2 plus 5 outcomes are here itself, right? But if you see the thing I printed here, if I probably print several times here, right, the results would go off. My earlier results, I need to scroll back and see what was the results for these things. But here in this case, it will be like outcomes are at that line itself, where the use case would comes in when you want to have probably the results to be there beneath that. That point of time can give you better results. I mean, graphs can be within just in the output section here if you want to use that way, right? Those things are there. To download RStudio as well as Anaconda in order to jump in and do some hands-on on Python or R. And various type of machine learning we saw, and various case studies of the data science and machine learning we saw. Various programming languages, the core component of the programming languages are available. The R and Python are the core programming languages that are used in um, like data science and machine learning. And the installation links are provided for that, and the first code was provided. All those things are there. This by the end of this course, you probably will get uh, the code for this. This will be shared. Sublime text. These are the bit easy stuff in order to, if you have installed your Python correctly with the variable in the environment variables are set properly. That point of time it will be very intuitive enough use case and handy if you use Sublime text, but it will not give you a chance to run the code line by line, which I'm sure both PyCharm and Sublime will not give you another curve to look into the variables. So PyCharm and Sublime text will not give you a way to see the parameters here. So it is telling that this parameter is a tuple and what sort of data it is having. Let's say this is my data actually. So the X values consist of lot of things. You cannot see that the variable content in other programming language. or you cannot run line by line, right? That is what it gives you another curve there. See, the journey of data scientist to get to that position is you need to get basics of what the core thing should be strong. What actually classification is, what actually predictive analytics is. All those things, you have a clear picture of these verticals. That point, no matter any programming language comes in, your basics are strong, right? Then that one of time you can justify things that you are aware of data science stuff, and you can crack some of the interviews there. This would drive you to data engineering stuff. We are gathering the data and maintaining the data in the Hadoop clusters, right? Those time people would say rather than data scientists, yeah, the roles in data science are there in this for Hadoop and all those things, but rather the role would be data engineer, right? Data engineering stuff, gathering the data and all those things. Probably basics of Python is enough because various packages are available for data science such as NumPy, SciPy, Matplotlib, or Python, TensorFlow, and all those things. That packages, if you are aware of some of the functions there, you could be very good at data science stuff.
All right. I think we had a really good session. Thank you so much for the information. And guys, I think you had a really good session. Any feedback with regards to the training program, what you guys had right now? You can put it in the chat box, and later we'll be uploading it. And for now, just to give a quick brief about the training program, we do have a very comprehensive training program with Intellipaat. Like you guys just had a overview about this training program, how it's going to be. We have the batch scheduled for this weekend. If anybody of you guys are interested in signing up for this course, you can come to the chat, and anybody from the registration team will help you for the registration. And we do have some really good, exciting offers going on for this month. We do have a flat 15% discount going on. Apart from which, we will also be giving you the self-paced learning absolutely free of cost. The self-paced learning content consists the content, the course content, what we are going to cover up. And like you just had the demo session, what we are going to cover in this training program, you're going to understand the machine learning algorithms. You're going to study the tools, techniques about the data science. Apart from which, you're also going to learn about the basics of the big data, ways to integrate R with Hadoop, things like that. And yeah, so if you have any questions, any clarifications, you can come to our website. You will have a chat window coming up. You will have my colleague Christy or Alex on the chat. You can put your questions over there. We could also arrange a call back if you want to have a one-on-one discussion with the registration team. We could help you with that. Along with the, like I said, along with the self-paced learning, we also give you a complimentary course that is the SAS and MS Excel, so that you have a better hands-on experience and a really good learning experience with us. So this is going to be an end-to-end training program with an instructor which you just had, wherein you are looking at having a deep dive information with regards to the course content, along with good hands-on experience working on the real-time projects. All right. So that's it from our end. And anybody interested in any the data science training program can come to our company website. That's www.intellipaat.com. And once you come up to our website, you'll have the chat window open. It's either going to be Christy or Alex. You can give them your details so that they could pass on your details to the registration team, and anybody from the registration team can call you and help you for the registration. And make it as soon as possible, because this is a very limited period offer what we have. 50%, 15%, 1/5 flat discount, and on the self-paced training. And that's it from our end. Thank you so much.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.